Hello, my name is Devin Hua, and this is Smart Space. Objectives and goals. This project matters because people need to monitor their IoT devices. Real-time data allows you to react fast, and Smart Space visualizes this data in an easy-to-use, friendly dashboard. Key features. Some functional features include user registration and authentication, the ability to view real-time device data, and export as a CSV. Some non-functional include token expiration and refresh tokens, performance under live updates, and UI compatibility for multiple screens. Architecture and how it works. Each device is an object with 3 entries: the device name, the value, and the time it was read. The system architecture. Front end sends HTTP requests to the back end, and the back end gets the data from the IoT simulation layer and sends it back to the front end. The tech stack. On the front end, I use React and Recharts. On the back end, I use Node.js and Express.js for the server. For the database, I use the browser local storage as well as a local Mongo database. For authentication, I use JSON Web Tokens, and for data, I generate mock data and I pull that data every 15 seconds. For the backend endpoints, I have 2 GET requests. The first one is to get the device data and display it in the charts. The second one is to get the user data and display it and make a more personalized dashboard. And I have 2 post requests. The first one is a register post request that allows the user to be put into the dashboard, into the database. It also hashes the password because you never store a password in plain sight. And lastly, the login logs in and authenticates the user and gives the user a JSON Web Token to stay logged in for an hour. A typical user flow consists of a user signing up, they log in, they see the dashboard, the dashboard displays live device data, and now they have 2 actions. They can press a button to retrieve the latest data at the moment the button was pressed, or they can press another button to export all the data as a CSV. For a demonstration, here's Smart Space, your real-time IoT dashboard. I'm going to click Get Started. It brings me to the login page. I don't have an account, so I will click Sign Up. I'm going to put my name, Devin Hua, and a secure password. Sign up. I get an alert that says user registered successfully. It redirects me to login. I will log in using the same information. Login. Hello, Devin Hua. Go to your dashboard. If I check the MongoDB database, I click refresh. As you can see, here's my username and password, and the password is hashed as we expect it to be. I click this arrow and it brings me to my dashboard. Here the dashboard includes current temperature, air quality, room occupancy, and the charts, which update every 15 seconds. So currently at 26 seconds, we expect the next one to appear at 41. There you go, 41. I also have the option, if I don't want to wait, I could click this button to get the reading of the next data at the moment the button was pressed, so 50, 52, 53, 54. I also have the option to download as a CSV. I download it. Here's a CSV, including the device, the value, and the timestamp. Some challenges and solutions. My biggest challenge was fetching API data for each component. Each call created its own state, and because of that, each chart was calling my API 3 times. So what I did instead was I called it once in the dashboard and passed that down as a prop to each component. And this reduced the number of API calls by 3. I couldn't get a button to access the newest data. So instead, I altered the hook to expose the data and the fetching function. Future improvements include access tokens and refresh tokens, changing from a local Mongo database to a cloud database, replacing mock data with real sensor streams, role-based access control, and make user authorization global, and this is more for like a UI UX experience. In conclusion, I built a full-stack IoT monitoring dashboard using React, Node.js, and Mongo database. I designed and exposed secure REST APIs with JSON Web Token-based authentication, implementing real-time data simulation and live updates. I applied scalable backend architecture practices, and I designed the system to be production extendable. Thank you.